This is another example here. A shaft rotating at 200 rpm drives another shaft at 300 rpm and transmit 6 kW through a belt. The belt is a 100 mm wide and 10 mm thick. The distance between the shaft is a 4 meter. The smaller pulley is a 0.5 meter diameter. Calculate the stress in the belt if it is first an open belt drive, and if second case if cross belt drive. Take mu value is equal to 0.3. So here this coefficient of friction is given, diameter values are given, and they are asked to find out the stresses in the belt. So stresses in the belt, we have formula. And that formula we observe in creep term. In creep term we observe that formula stress value sigma, and also in maximum tension in the belt we can calculate as a sigma bt. Maximum tension in the belt we can calculate as a sigma bt. The two formula, we go through these two formula having that stress component. Sigma may be in previous PT it is denoted as a F value. So stress value, that stress value term we observe in two formulas, in creep formula and in maximum tension formula. So in creep formula we required Young's modulus. Also this Young's modulus, if you observe in this example, this Young's modulus is not given in this example. So this creep formula we cannot use it here. So second formula having stress term is nothing but a maximum tension is equal to sigma bt. Now B is nothing but width and T is nothing but thickness of that particular belt. So if you look at this example, this width and thickness is given to you. So we can use here that second formula, maximum tension is equal to sigma bt. Now bt value is given to you. So task is now must be T1 calculation. Task is the T1 calculation, maximum tension calculation. That you can again calculate by using our previous notations. Our previous formula 2.3 log T1 by T2 is equal to mu theta. So then by using this formula we can find out the T1. Value. Now, so find out this T1 value. Now if you look at this, now we use formula T1 is equal to sigma pt. B is known to you, T is known to T1. So calculation of T1 we use formula 2.3 log T1 by T2 is equal to mu theta. Now here in this case we should know T1 and T2. We should know T1, T2 and mu theta. Mu is given to 0.3. Theta, that theta is we have to calculate. For theta we have to calculate. Again theta we have to calculate. Mu is given to you, T1, T2. Again we have to calculate. So first we find out the theta value. Now for theta, for open belt drive and for crossed belt drive. For open belt drive theta, and there are two cases are given of an open belt drive and cross belt drive. So we will calculate the theta for open belt drive and calculate theta for the crossed belt drive. So here that angle of contact on the smaller pulley consider. So for open belt drive, this alpha is equal to R1 minus R2 by x. So this alpha becomes, and 180 minus 2 alpha is nothing but the angle of contact for the open belt drive. So first we calculate for the open belt drive, and then you calculate for the crossed belt drive. Again crossed belt drive theta is calculated 180 degree plus 2 alpha, and sin alpha is equal to R1 plus R2 by x. So for first open belt drive, we have to calculate. So for this open belt drive, this alpha you can calculate, theta you can calculate. velocity is equal to pi d2 n2 by 60. Pi d2 n2 by 60. Pi velocity of the belt. Pi into d2. D2 is given as a 0.5 meter. 0.5 meter. Smaller pulley 0.5 meter is given to you. The speed of that pulley is given as a 300 rpm. Speed of that pulley is given as a 300 rpm divided by 60. So 7.855 meter per second is the linear velocity of that particular belt. So V is calculated here. V is calculated here. N2 by N1 is equal to D1 by D2. From this formula, N2 is given, N1 is given, D1 is given, D1 is given, and that D1 is given, and we have to find out D2. D2 is given, we have to find out D1 0.75 meter here. Now this case is for the open welder. We calculate for the open welder. So these formulas are for the open welder. This angle of contact formula is for the open welder. This formula is same for both the cases, velocity. This but angle of contact formula is separate for the open welder and cross welder. In cross welder, these are plus, these are plus, these are also plus. Now here are T1, T2 are unknown. T1, T2 are unknown. So we put whatever that known quantity in this formula. So 2.3 log T1 by T2 unknown is equal to mu theta. Mu is 0.3. Theta we already calculated. 3.08 radian. 3.08 radian. Put here, and it becomes as a 0.924. 0.924. 924. And this. Now we get relation in between T1 T2. T1 T2 is equal to 2.52. Again power transmitted is equal to T1 minus T2 into V. Power transmitted given here. Power transmitted given here 6 kilowatt. 6 kilowatt. So put in this formula 6 into 10 raised to 3 is equal to T1 minus T2 into V. Velocity we already calculated here 7.854. Put here 7.855, 6 into 10 raised to 3, T1 minus T2. So T1 minus T2 is now becomes as a 764 meter. Now these two relations, by using these two relations, this T1 by T2 is equal to this 2.52 and T1 minus T2 is equal to 764 Newton. This, by using these two relations, we can find out the T1 and T2. We can find out by simplifying these two equations, find out T1, T2. And then we put from this T1 T2. From this T1 T2, maximum tension is this 1267 meter. So put this T is equal to sigma Bt. So B is known to you, T is known to you, T is known to you, B known to you, thickness T is known to you, and find out sigma. This is for open belt drive. This is for the open belt drive. Now for cross belt drive, same procedure repeated. Only angle of contact is changing in this case. Angle of contact now sin alpha is equal to R1 plus R2 by X and theta is equal to 180 degree plus 2 alpha. These are the small changes in the cross belt drive. All other procedure remains same. So theta is changing here. In open belt drive this theta is different, and in cross belt drive this theta is different. Put the theta here, that is calculated for cross belt drive 3.4456. You put here 0.3 mu, and then you can find out T1 by T2 value, and by simplifying this T1 by T2 and this first equation, this first T1 minus T2 into this, we can calculate this T1 T2. Now from this T1 T2, this 1184 Newton is maximum. 1184 is equal to 6 B sigma Bt. Say is equal to sigma Bt. That B is known to you, T is known to you, and you can find out sigma stress value. So this formula use all the formulas. This example use all the formulas that we studied in the belt drive topic. That we studied in the belt drive topic. So this is the another example. So leather belt is given. A leather belt is required to transmit 7.5 kilowatt from a pulley 1.2 meter in diameter, running at 250 rpm. The angle embraced is 165 degree, and the coefficient of friction between the belt and the pulley is 0.3. If shape working stress for the leather belt is 1.5 megapascal, density of that leather is 1 milligram per meter cube, and thickness of the belt is 10 millimeter. Determine the width of that belt taking centrifugal tension into account. So they are asked to consider centrifugal tension. They are asked to consider centrifugal tension, and by considering centrifugal tension, we have to calculate width of that belt. We have to calculate width of that particular belt. So B is unknown here. B is unknown. Now here that shape working stress is also given. Shape working stress. So formula having working stress value, width value, thickness value, which is having maximum tension formula. Maximum tension T is equal to sigma Bt. That formula we can use here. So sigma Bt or sigma Bt, B is unknown here. B is unknown here. Thickness is given here. Sigma is also given here. And T is unknown here. Now T we have to calculate. Maximum tension value we have to calculate. And that tension value we calculated again by similarly that we discussed in previous example. By considering this example, this formula 2.3 log T1 by T2 mu theta, and another formula, power formula, P is equal to T1 minus T2. So by using these two formula, we get relation in between T1 and T2. After simplification, we can find out T1, T2, and from this T1, T2, find out whatever which is the maximum value. This is nothing but a maximum tension value that we can put in this formula. T is equal to sigma Bt. And now here some centrifugal tension is considered. Centrifugal tension is considered Tc. So T is nothing but a T1 plus Tc. T1 plus Tc. And then we move further and we can find out the answer. Now, first we write down that whatever that given quantity, power is given. Belt is used to transfer power 7.5 kilowatt. So in watt it is a 7500 watt. D pulley diameter is given 1.2 meter diameter. D is 1.2. N is a 2.50 rpm. Angle of embrasure is 165 degree. Converted into radian. So it becomes a 2.88 radian. Coefficient of friction mu is given 0.3. Shape working stress sigma is given as a 1.5 megapascal. Say sigma is equal to 1.5 megapascal. Density is given. Density of the leather is given 1 mg per meter cube. 1 mg per meter cube. That is also given, and thickness of the belt is given as a 10 millimeter, and they asked to find out the width of that particular belt considering centrifugal tension. So we have to find out the width. Now we use that formula, power formula is equal to T1 minus T2 into V. Now V is nothing but a pi dN by 60. D is known to you 1.2, D is given, N is given, and we can find out that V value, velocity value, T1, T2 value that are unknown to us. Power value is given 7500 watt. So we get relation in between T1 minus T2 is equal to this much. Now we have another equation or another relation in between T1 T2. 2.3 log T1 by T2 is equal to mu theta. So we put this value, mu value 0.3, theta value is 2.88 calculated here, and we get another equation for this T1 T2, another relation for this T1 T2. T1 by T2 is equal to this much. By simplifying these two equations, T1 minus T2 is equal to this, T1 by T2 is equal to this. Simplifying these two equations, we will find that T1 is equal to this much, T2 is equal to this much. So So by observing these two values, this is the higher value, 824.6 Newton, which is the maximum tension. This maximum tension we can consider. Now here centrifugal tension also they are asked to consider. Now centrifugal tension is equal to mv square. Centrifugal tension is equal to mv square. Tc is equal to. So velocity we already calculated 15.71. Velocity I calculated 15.71 meter per second. But this m is not known to us. This m is not known to us. This m is nothing but a mass. M is nothing but a mass. But here density is given to you. Density is given to you. So density is given to you. So density is nothing but a mass per unit of volume. Density is nothing but a mass per unit of volume. So mass per unit of volume. Mass per unit of volume. So that volume is nothing but area into length. Mass divided by volume. This volume. Area into length is nothing but volume. Mass per unit of volume is nothing but density. So area into length is density, volume. Area into length is the volume. So area is nothing but width into thickness. Area is nothing but width into thickness. B into thickness is a 0.01. Length is given as a 1 meter. Length is given as 1 meter. And mass per unit volume is equal to density. So mass is equal to density into this volume. Area into length. So area is B into thickness. Area is nothing but width into thickness, B into 0.01, length is 1 meter, density is given as 1000 kg per meter, 1000 kg per meter cube. So it is a 10 this mass value in terms of width 10 kg. Put here the TC value. Put here TC is equal to mv square. Mass is a 10b. V is nothing but 15.71 square. So it becomes 2468 B Newton. So T, we have maximum tension formula. Maximum tension is equal to sigma Bt. Sigma is given. B is unknown. T is a 101 is equal to this much. T is equal to in terms of this. So T is equal to this tension now considered as by considering centrifugal tension, introducing centrifugal tension. So T now becomes as a T1 plus TC. T is now become T1 plus TC. T1 is given as a calculated as per here 824.6 plus TC this 2468B. Now is this must be equal to this equate to this. And we have to calculate it. Now in this equation only unknown is B. So find out that B value. Find out B value which is asking quantity. Find out B value which is asking quantity. So here we find out that B value. Here we use all the formulas. Centrifugal tension formula, maximum tension formula, again power transmitted formula, relation in between tension, velocity formula, and then we find out that B value. Again density formula, mass per unit of volume. Mass per unit of volume is nothing but density. Density is given, area is given, length is given. So mass we have calculated here. So we use this formula and find out that value. Now this next example, in this next example, determine the width of that 9.75 millimeter thick leather belt required to transmit 15 kilowatt from a motor running at 900 rpm. The diameter of the driving pulley of the motor is 300 millimeter. The driving pulley runs at 300 rpm and the distance between the center of the two pulleys is 3 meters. Distance between the two pulleys is 3 meters is given to you. Now here this example. So here given that width equal to 9.75 millimeter converted into meter. Power is given 15 kilowatt converted into watt, 1500 to 3. N1 motor RPM is given 900 RPM. Diameter is given 300 millimeter. converted into meter, 0.3 meter. N2 driven pulley speed is given as a 300 rpm. Center distance is given as a 3 meter. Distance between two pulleys is given as a 3 meter. Density is given as a 1000. Now here this is given condition with 3 meters. This example is continued here also. 1000 meter kg per meter cube. This density is also given. Sigma value allowable stress is also given 2.5 megapascal. 2.5 megapascal, that is also given. Coefficient of friction between laser and pulley is given 0.3, and then they have to ask to find out the determine the width of that particular belt. Determine the width of that particular belt having thickness 9.75 millimeter. So T is equal to 9.75 millimeter. So we can find out. Now again same formula we can use. That T is equal to sigma Bt. Now we can simplify. So N2, N1 are given. One diameter D1 is given. So D2 we can find out like this. Velocity we can find out pi D1 N1 by 60. So velocity we can know this velocity. Find out so this is open belt drive. Here it is given as assume open belt drive and neglect this slip of the belt. Neglect sag and slip of the belt. So that slip is also neglected. So open belt drive consideration. Find out the theta is equal to 180 degree minus 2 alpha. Alpha sin alpha is equal to R2 minus R1 by x. D2 minus D2 divided by 2x. D2 is 0.9 minus 0.3 divided by 2 into 3 is equal to 0.1. So alpha is equal to this much. Theta is equal to 180 degree minus 2 alpha. 1 degree minus 2 alpha is equal to this much. So by another relation in between T1 T2 is equal to 0.3 log T1 by T2 is equal to mu theta. So mu is given, theta we already calculated here 2.94, and we get relation T1 by T2 here. Power transmission again that is given 15 into 10 raised to 3 T1 minus T2 into V, that also given. So T1 minus T2 relation we can get as a 10-16 Newton. Simplify these two equations, we will get T1 is equal to this much. Now mass value you can find out. TC is considered here as a mu square. V we already calculated here. Mass value we can calculate as a density is nothing but mass point of volume. Volume is nothing but area into length. Volume is nothing but cross-sectional area into length. Area is nothing but width into thickness. B into T, width into thickness area. Length is L into density 1000, which is nothing but mass. In terms of kg. Now here width is not known to you, so mass comes in terms of width B. So Tc is given to mu square. T considered as a sigma Bt. So sigma is known to you 2.5 into 10 raised to 6 into B into T 9.75 into 10 raised to 3, which are given to you. That again calculated in terms of B. Now T is equal to T1 plus Tc. T is equal to T1 plus Tc, and again we put this value. T minus Tc is equal to T1. T minus Tc is equal to T1. This T1 value we already calculated 1806. 1806 is equal to T is equal to T here calculated. 24,400 B minus T1. Minus T1 you calculated as a minus Tc. Minus Tc you have calculated as a this much. 1950 B is equal to 1806 Newton. So that simplification we will give. That simplification give this B value as a 0.08 meter. So this is again similar to the previous example. Again very similar to previous example. These are the numerical space around this belt. the numerical based on the again we go further with some numericals and then this topic will be finished.